Hey everyone, and welcome back. Today we're diving into a really ambitious Proxmox Homelab project.
Oh, yeah, this one's exciting.
So our listener wants to set up a high availability cluster, and they've picked out some interesting hardware to do it.
Some pretty cool hardware, actually.
We're talking AM06 Pro Mini PCs,
Those are sweet.
a Dell Optiplex,
Nice.
and they're going to be using a mix of NVM and SATA SSDs.
Oh, wow, a mix of those. That's interesting.
Yeah, it's like a Frankenstein build.
I like it. Resourceful.
But like any good home lab project,
Oh, yeah.
there are some challenges.
Always challenges.
So we've got limited storage to work with.
Okay.
Network bandwidth is capped at 2.5 GBE.
Hmm.
No ECC memory.
All right.
And get this, only 2 nodes for the cluster.
2 nodes. Wow, that's going to be a fun one to figure out.
Yeah, so it's like trying to build a fortress on a shoestring budget.
Exactly. You got to get creative.
You got to be super resourceful.
That's what I love about home labbing, though, right?
Yeah.
It's like you're pushing the boundaries of what you can do with limited resources. Absolutely.
It's like this constant puzzle.
It is. So let's break this down a little bit.
Okay, sounds good.
First things first, high availability, or HA.
Right.
Can you walk us through what that actually means?
Sure. So imagine your home lab as like a busy city, right?
Okay.
With essential services running all the time.
Like what kind of services?
Oh, file sharing. Maybe you've got an ad blocker running.
I see.
High availability is like having a backup power grid for that whole city.
Okay, I'm starting to get the picture.
So if one system crashes, let's say your file server goes down, another machine in your cluster can just instantly take over.
Wow, so no downtime.
Exactly. No interruptions. Everything keeps running smoothly.
So it's like an insurance policy for your home lab.
Exactly. It's all about that digital resilience.
I like it. It's like peace of mind knowing everything will keep running.
Exactly.
But how is that different from what like a big company would do?
Oh, yeah. Good question.
Because they have a lot more resources. Way more, yeah. Think of an enterprise set up as like a mega city.
Okay.
With multiple power plants, backup generators, the whole 9 yards.
Gotcha.
They might use solutions like Ceph, which is like having this massive distributed power grid across multiple buildings.
That sounds intense.
It is. It's super robust, but also really expensive and uses a ton of power.
Yeah, I can see how that wouldn't be ideal for a home lab.
Yeah, not really practical when you're watching your budget and your electricity bill.
Exactly. So you're trying to achieve that same level of resilience, but on a smaller, more energy-efficient scale.
Precisely.
And you've got a pretty interesting mix of hardware to do it with.
Yeah, I'm curious about those AM06 Pro Mini PCs.
Me too. They're getting a lot of buzz in the home lab community these days.
Yeah, and for good reason. They're powerful little machines.
Yeah, but they're energy efficient too.
Yeah, like sipping energy, not guzzling it.
I like that analogy.
And those Ryzen processors, the 5800U and the 5700U, those are perfect for virtualization.
Yeah, they strike a nice balance between performance and efficiency.
For sure.
And you've got one of each, right?
I do, yeah.
What's the thought behind having different processors in the nodes?
That's a great question. The performance difference between the two is actually pretty slight.
Oh, really?
Yeah, but it's something to consider if you're planning to run like really demanding virtual machines.
Or if you're like really into optimizing the load balancing across your cluster.
Yeah, exactly. If you're that kind of person who wants to squeeze every ounce of performance out of their system.
I can definitely see that.
Yeah, it's something to think about for sure.
Okay, let's talk storage.
All right, diving into the storage world.
You've got a mix of NVMe and SATA SSDs in each of those mini PCs.
I do.
It's like having a high-speed express lane and a regular lane on a highway.
I like that analogy. It's perfect.
Yeah.
So those NVMe drives, those are your express lanes.
What?
They're the best for running Proxmox itself
Okay.
and any virtual machines that just need super fast performance.
So like, give me an example of a VM that needs that kind of speed.
Oh, let's say you're running a database server.
Gotcha.
Something that's constantly reading and writing data.
So the NVMe drives are like giving those applications a turbo boost.
Exactly.
What about the SATA drives then? What are those good for?
So those are more for your everyday traffic, things that don't need to be in the fast lane.
Okay, like what?
You know, maybe a VM running a simple web server.
Gotcha.
Or maybe just for storing files that you don't access very often.
So you're being strategic about where you put things?
Always got to be strategic with storage space, especially in a home lab.
And speaking of strategic,
Yeah.
you've decided to use the SATA drives in your Dell Optiplex to create a ZFS mirror.
Yeah, Dell's got some extra SATA ports, so why not put them to good use, right?
Exactly. So that gives you some redundancy.
If one drive fails, the other one keeps chugging along.
Huh? That's a smart move, especially since you're working with limited storage overall.
Yeah, every little bit helps.
But with only one NVMe and one SATA drive per device, storage space is going to be a challenge.
It is. It's definitely a constraint we need to be aware of.
It's like packing for a trip with only a small suitcase.
Exactly. You've got to prioritize the essentials.
And get creative with how you fit everything in.
Uh-huh. Exactly.
All right, so it's not just storage space that we need to consider here.
Right. What else is there?
I'm a little concerned about heat,
Heat. Yeah, those AM6 Pros can run a little warm.
especially with both types of SSDs going at it.
That's true. We'll need to think about some cooling strategies.
Definitely. We don't want anything overheating.
Right. So we've got heat as a potential issue.
Yeah, and then there's that 2.5 GBE network.
Right. The network.
I'm wondering if that's going to be a bottleneck,
Yeah, especially for storage replication.
especially with all that data being mirrored between the nodes.
Yeah, 2.5 GBE isn't exactly ideal for high-speed storage replication.
It's like trying to move a mountain of stuff through a narrow doorway.
It's going to take a while.
So we'll need to optimize the network configuration as much as possible.
Definitely. Every little bit of optimization helps.
And then there's the decision to go without ECC memory.
Right, the ECC memory.
That's a bold move,
It is, but it's a trade-off a lot of Homelabers make.
because ECC memory adds a layer of protection,
It does, yeah. Helps prevent data corruption.
but it also adds to the cost.
And in a home lab, sometimes you got to make tough choices.
Got to balance that cost with the risk.
Exactly. It's all about finding that balance.
So in this case, you're accepting a slightly higher risk,
Yeah,
but it means we need to be extra careful about backups,
absolutely. Backups are crucial in any home lab setup.
especially one where you're not using ECC memory.
Right. Backups are like your safety net.
They're your insurance policy.
Exactly. If something goes wrong, you can restore from a backup and get back up and running.
And last but not least, let's talk about the decision to use just 2 nodes for the cluster.
Ah, yes, the two-node dilemma.
It's a bit unconventional for high availability, isn't it?
It is. Most people aim for 3 nodes.
Yeah, because 3 nodes gives you more redundancy.
It does.
And it helps avoid that split brain scenario.
Oh, yeah, split brain. That's a nasty one.
It is. It's like 2 halves of a brain that can't communicate with each other.
Yeah, it can really mess things up in a cluster.
But you've come up with an interesting workaround.
I have the Q device.
Q device. Tell me more about that.
All right, so the Q device is basically like having a 3rd node,
Okay.
but without the cost of another physical server.
So it's a virtual node.
Exactly. It's a lightweight Proxmox installation that runs on your Dell Optiplex.
I see. And it participates in the cluster's decision-making process.
It does, yeah. It's like the tiebreaker.
So if the connection between the 2 main nodes goes down, the Q device steps in.
Exactly, and it prevents that split brain situation.
That's brilliant. It's like having a wise old sage who keeps everything in harmony.
I like that. It's all about working smarter, not harder.
I love it. Okay, so we've got our hardware, we understand high availability, and we've identified some challenges.
Yeah, we've laid the groundwork.
Now, how do we actually configure all of this to work together?
The fun part. That's what we'll dive into next.
I can't wait. This is where things get really interesting.
We'll walk through the whole process step by step.
So stay tuned. We'll be right back with part 2 of our deep dive into this amazing Proxmox HA project.
I'm excited for this one.
Okay, so let's actually get our hands dirty.
Let's do it.
Let's set up this Proxmox HA cluster.
Time to put all the pieces together.
Yeah, it's like we've got all these ingredients.
Right.
Now we're going to make something delicious.
The tech feast.
Exactly. So where do we even begin?
Well, first things first, we need to install Proxmox on each of your nodes.
Okay.
Those awesome AM06 Pro Mini PCs.
Right.
Remember those NVMe drives we talked about?
Super fast ones?
Exactly. That's where Proxmox is going to live.
Okay, makes sense.
Give it that speed boost it needs.
So we want our hypervisor, like the brains of the operation,
Yeah,
to have the quickest access to storage.
absolutely. It's like giving the chef a dedicated express lane to the pantry.
Perfect analogy.
Got to keep those ingredients flowing.
Exactly. So how do we actually install Proxmox?
It's pretty straightforward, actually.
Oh, good.
Proxmox makes it really easy.
Oh,
You just download the ISO image, flash it onto a USB drive,
okay.
and then boot from that USB drive on each of the AM06 Pros.
Gotcha.
The
Okay.
installer will walk you through the rest.
Easy peasy.
Yeah, it's surprisingly user-friendly, even for someone who's never used Proxmox before.
So no need to be intimidated.
Nope, anyone can do it.
Awesome. Okay, so once we have Proxmox installed on both nodes, what's next?
Then we move on to the network configuration.
Okay, networking.
This is where we need to be a little bit more strategic.
Right, because we have 2 network interfaces on each node.
Exactly, we've got the 1 GBE and the 2.5 GBE.
So remind me again, what's our plan here?
Okay, so the plan is to dedicate those 1 GBE connections for management traffic
Okay.
and the 2.5 GBE for everything else.
Storage replication, VM traffic, all that.
Yep, all of it.
It's all about maximizing efficiency and avoiding bottlenecks.
Exactly. Got to keep things running smoothly.
So how do we actually configure the network settings within Proxmox?
Okay, so within Proxmox, you'll assign that 1 GBE interface to the management network.
Management network. Okay.
This is where ChorusSync will be working its magic.
Yes, ChorusSync, the cluster communication protocol.
The glue that holds everything together.
Keeps those nodes in sync.
Exactly. Think of it like a messenger,
Okay.
constantly running between your nodes, making sure they're talking to each other.
And sharing information quickly.
Yeah, low latency is really important for that communication.
And the 1 GBE connection should be plenty for that.
More than enough.
Okay, good. So even though the 2.5 GBE might not be ideal for storage replication,
Right.
it's fine for ChorusSync.
Perfect for ChorusSync.
And then we configure the 2.5 GBE interface for everything else.
Exactly, for storage replication and all your VM traffic.
Right. We'd ideally have separate networks for those.
Yeah, ideally.
But with our limited hardware,
Right.
we have to share.
We do. It's like having a 2-lane highway,
Right.
handling both passenger cars and those big trucks.
So we need to manage the traffic flow carefully.
No, we do. We can use VLANs for that.
Right.
Those can help segregate the traffic.
Creating virtual lanes on our highway.
Exactly.
Keep everything organized.
And hopefully improve performance a bit.
Okay, so we've got Proxmox installed, network configured.
Check and check.
Now it's time for our secret weapon,
Ah, yes, the Q device.
the Q device.
Our virtual third node.
So how do we bring that online?
We're going to install Proxmox on your Dell Optiplex.
Just like we did with the Ammo 6 Pros.
Exactly the same process.
But this time,
This time, it's not running any VMs.
it's just there for the Q device.
Its sole purpose in life is to be the Q device.
So it's a very minimalist Proxmox installation,
Extremely minimalist.
focused on keeping the cluster running smoothly.
Exactly. It's like the control tower at an airport.
Okay, I like that.
It doesn't fly any planes,
Right.
so to make sure everything runs on time.
Keeps everything organized.
Exactly.
Prevents any collisions.
Exactly.
Okay, so once Proxmox is installed on the Dell Optiplex,
Then we integrate it into the cluster as the Q device,
and there you have it.
a 3-node cluster.
Even though we only have 2 physical servers.
It's a thing of beauty.
It is. Okay, so now let's talk about ZFS replication.
Ah, yes, CFS replication.
The magic that keeps your VMs in sync.
The heart of our high availability setup.
This is what gives us that real-time failover capability.
Exactly. If one node goes down, the other one can instantly take over.
Seamlessly, no interruption.
Like a pair of synchronized dancers.
Okay.
Every move one makes, the other one mirrors it instantly.
I love that analogy.
ZFS replication is kind of like that.
It's creating a perfect copy of your VM data on the other node.
Exactly. So any changes you make on one node are automatically reflected on the other.
So both nodes always have an up-to-date copy.
Always up to date, always in sync.
That's awesome, so it just happens in the background.
You don't even have to think about it.
But there are some things we need to keep in mind when setting it up right.
Yeah, there are a few things.
Like what?
Well, we can choose how often we want that replication to occur.
Okay, so how often should we replicate?
It depends.
On what?
Well, how critical is the VM?
Oh,
For example, let's say you have a VM running Pi-hole.
that's my favorite ad blocker.
Yeah, it's a good one.
We don't want any interruptions to our ad blocking.
Exactly. So in that case, we might want to replicate changes every few minutes.
Keep things super up to date.
Exactly.
But for a VM that's just used for testing,
Right, something less critical.
we could replicate less often.
Much less often. Maybe once a day, maybe even less.
So it's a trade-off between redundancy and performance.
Always a trade-off.
We want to protect our data, but we don't want to overload the network.
Right, it's about finding that balance.
Okay, so another important thing with ZFS replication,
What's that?
snapshots.
Snapshots. Those are lifesavers.
I love snapshots.
They're like having a rewind button.
Exactly. So if something goes wrong,
Uh-oh.
you could just revert to a previous snapshot
Back to a known good state.
and you're back in business.
Exactly. No harm done.
And snapshots are also great for testing.
Oh, yeah, perfect for testing.
You can try out different configurations.
Experiment all you want.
If you don't like the results, just discard the snapshot.
It's like a safety net for your VMs.
I love it. Okay, so we've talked a lot about ZFS replication,
We have.
how it provides this real-time redundancy.
It keeps those VMs in sync.
But you said earlier that replication is not the same as a backup.
Right. Important distinction.
So can you explain the difference?
Sure. Imagine you have 2 copies of a book,
Okay.
one on each side of your desk.
Okay.
ZFS replication is like having those 2 copies.
It's always identical.
Exactly.
So if you spill coffee on one,
Uh-oh.
You still have the other one.
Right, you're good.
But what if your house catches fire?
Oh, no.
Both copies are gone.
Doesn't matter how well synchronized they were.
That's a good point. So ZFS replication protects us from a single node failure, but not from a catastrophic event.
Right, something that takes out the whole cluster.
And that's where backups come in.
Backups are your ultimate safety net.
It's like having copies of your books stored in a fireproof vault.
Exactly. Even if disaster strikes, those backups will survive.
So even with our amazing HA setup,
Even with all the bells and whistles.
we still need backups.
Always need backups.
Okay, so how do we actually create backups in Proxmox?
Proxmox makes it really easy.
Oh, good.
You can schedule regular backups of your entire setup.
VMs, configurations, everything.
Everything, and you store those backups on a separate device.
Like a NAS.
Perfect. And NAS is a great option.
So our backups are completely independent from the cluster.
Totally isolated.
So even if the worst happens,
Knock on wood.
we can restore everything.
Back to normal.
I think it's like that extra layer of insurance.
Peace of mind knowing your data is safe.
All right, so we've covered a ton of stuff.
We have.
Proxmox installation, network configuration, the Q device.
ZFS replication, backups.
We even talked about heat.
Can't forget about heat.
Got to keep those AMO6 Pros cool.
Definitely. We don't want any meltdowns.
So what have we learned?
I think we've shown that high availability isn't just for big companies.
It's achievable in a home lab
On a budget.
with a bit of creativity.
And a lot of resourcefulness.
Exactly. It's all about making smart choices.
And understanding the trade-offs.
And I think the most important takeaway is
What's that?
it's about that spirit of experimentation.
The Homelab spirit.
It's about pushing the limits
Trying new things.
and having fun.
Exactly. That's what it's all about.
So keep that spirit alive.
Keep learning. Keep experimenting.
And keep building amazing things.
Cheers to that.
Absolutely. Thanks for joining us.
It's been a blast.
Until next time.
See you later.
Welcome back for the final part of our deep dive. It's been quite the journey.
It has. We've covered a lot of ground.
We've gone from picking out hardware
All those different components.
to the nitty-gritty details of Proxmox and ZFS replication.
Yeah, we really got into the weeds there.
I think our listener has a really solid plan now for high availability in their home lab,
They do. They've done a great job balancing the different factors.
especially considering the budget.
Yeah, they're working with some constraints.
I got those mini PCs, the older Dell acting as the Q device.
And that 2.5 GBE network.
It's like they're building a race car out of spare parts.
I love that analogy.
It's resourceful.
It's a bit rebellious, too.
It is. It's like they're not afraid to think outside the box.
That's what makes home labbing so fun.
Exactly. It's about understanding the why behind the technology.
Not just blindly following a checklist.
Right. We could have just said, here's how you set up a Proxmox cluster.
But we wanted to dive deeper.
We wanted to explain why things work the way they do.
Like why ZFS replication is so important for high availability.
And why you still need backups, even with a highly available setup.
Those are crucial concepts.
Exactly, because knowledge is power.
Especially when you're dealing with technology.
I think there's a bigger lesson here, too.
Oh, what's that?
It's about that home lab spirit.
Ah, yes, the home lab spirit.
It's about being curious.
It's about wanting to learn.
It's about experimenting and solving problems.
It's about not being afraid to break things.
And then fixing them.
Exactly.
It's about being a pioneer.
Forging your own path.
Our listener is a great example of that.
They are. They've shown that you don't need a ton of money to build something amazing.
Right, it's about resourcefulness.
It's about embracing
Right,
limitations.
and finding creative solutions.
They've turned those limitations into opportunities.
And they're going to end up with a highly available Proxmox cluster.
That's going to be rock solid.
And give them peace of mind knowing that their home lab can handle anything.
It's a great feeling knowing your services are always going to be there.
Exactly, no matter what happens.
And that frees you up to focus on the fun stuff.
Experimenting with new things.
Learning new technologies.
Building cool projects. So as we wrap up this deep dive,
It's been a pleasure.
I want to leave our listener with one final thought.
I'm listening.
Now that you have this highly available setup,
What are you going to do with it?
what are you going to build?
What are you going to explore?
The possibilities are endless.
That's the beauty of it.
So keep that home lab spirit burning bright.
Keep learning. Keep growing.
Keep pushing the limits.
And most importantly, have fun.
Thanks for joining us on this incredible journey.
It's been an honor.
Until next time.